a .50 caliber that flies. Power built for tanks, mounted on helicopters. This is the GAU-18A, the lightweight cannon that turned recoil into rhythm. Born from the Browning M2, stripped down and tuned for flight, it gave helicopters artillery strength without breaking them apart. Today I'm tearing open the GAU-18A, how it fires, and how engineers made a cannon you could hang from a helicopter door. If you love precision and chaos, subscribe and dive in. Let's get into how it actually works. At its core, the GAU-18A is a short recoil operated machine gun. It uses the energy from each shot to cycle the next. When the trigger is pressed, the firing pin lights the primer of a .50 BMG cartridge. The powder charge burns, generating high-pressure gas that drives the bullet forward and, by reaction, pushes the barrel and bolt rearward together. For the first small fraction of travel, they remain locked, a safety interval that prevents the breech from opening while chamber pressures are at their peak. When pressure drops, the bolt unlocks, the barrel halts, the bolt continues rearward, ejects the spent case, and compresses the recoil spring. As the spring returns, feed powels index the disintegrating belt, and the next round is chambered. Fire, recoil, eject, feed, lock. A mechanical cycle tuned for cadence rather than chaos. Engineers tune springs, buffers, and cam profiles so recoil energy spreads out over milliseconds instead of spiking, which makes the gun push more than it punches. That timing is what lets a .50 caliber system live on a helicopter door without wrecking the airframe. Designers also manage barrel harmonics and muzzle impulse, so successive shots remain aligned. Small changes in barrel length, mass and bedding affect dispersion and handling, so those choices are part of the balance between accuracy and weight. The GAU-18A uses a closed breech, Browning-style cycle, consistent with its family heritage. Its practical and commonly reported rate of fire for this variant falls in a conservative range of roughly 650 to 850 rounds per minute, depending on configuration. At that cadence, each burst is deliberately short, delivering decisive effect while limiting heat and recoil buildup. In practice, gunners control bursts to preserve barrel life and maintain aim, rather than relying on long, sustained fire. Feeding is simple and robust. Disintegrating metallic belts feed from ammo cans through flexible chutes, so gunners can swing without tangling. The feed uses pawls that advance and align rounds in a coordinated action to minimize jams even under vibration. Cooling depends on barrel mass, pauses between bursts, and wear-resistant bore treatments. Crews manage barrel life with discipline and routine swaps when necessary. Field maintenance practices, quick inspections of headspace, extractors, and feed pawls keep the mechanism reliable under harsh conditions. In short, the GAU-18A doesn't try to eliminate recoil. Instead, it times and channels it. The result is controlled, repeatable fire with predictable recoil impulse, a system a trained crew can use from a moving helicopter to place heavy rounds exactly where they're needed. The GAU-18A's brilliance isn't just how it fires, but how it fits into a helicopter's fragile balance of weight, lift, and vibration. Too much mass on one side upsets lift, but uncontrolled bursts upset stability. So the gun is mounted in a pintle cradle with a damped swivel bolted to the airframe. Hydraulic or spring isolators within the cradle soak up a significant portion of the recoil impulse before it reaches the fuselage. Think shock absorbers for a .50 caliber. The mount's geometry gives the gunner full elevation and azimuth, while built-in resistance keeps movement steady and predictable. Travel stops prevent the barrel from swinging into the rotor disc or tail boom, small safety details with outsized importance in flight. Ammo handling is engineered for reliability. Linked belts ride in sealed containers to keep grit and moisture out and feed through curved, flexible chutes that resist kinks. Spent links and casings are directed into collection containers, so nothing ricochets into moving parts. In action, it looks chaotic, but each element is designed to smooth feeding under vibration. The human element completes the design. A door gunner, tethered and dealing with rotor wash, must spot, aim, and fire in seconds. Ergonomics matter. Spade grips align with natural arm movement, triggers break crisply, and controls fall where the hand expects bursts are timed to the airframe's motion and pilot inputs. Too long and recoil walks the muzzle, however too short and rounds scatter. Training converts that timing into muscle memory. Ammo selection also matters. Crews choose armor-piercing for vehicles, incendiary for fuel tanks, tracers for visual correction, or mixed belts for flexibility. Each alters recoil and trajectory slightly, and experienced gunners compensate instinctively. Serviceability seals the package. The gun and its components are designed for field maintenance. The receiver and barrel assemblies permit routine inspection and replacement without heavy shops, a crucial feature for operations from austere bases. All of it, mount, feed path, ergonomics, and serviceability, follows one rule, which is maximum firepower with minimum interference. Pre-flight checks, routine lubrication, and alignment, including standard drills, keep the system reliable. The weapon also integrates with crew communications and sighting practices, so pilot and gunner coordinate movement and engagement precisely, turning design into dependable performance. Tactically, the GAU-18A fills the niche between rifle-caliber door guns and electrically driven Gatlings. It won't match a minigun's volume, but its .50 BMG rounds do what lighter calibers cannot: penetrate light armor, disable engines, and defeat hardened cover. Where a Gatling saturates, the GAU-18A punctures. That makes it vital for combat search and rescue, convoy overwatch, and low-altitude suppression. A helicopter equipped with GAU-18As can establish immediate suppression over a landing zone, buying medics and extraction teams the seconds they need. In maritime roles, it provides credible warning or disabling fire against small, fast boats without escalating to rockets. Newer designs offer higher rates of fire and advanced recoil systems, but they often require heavier mounts, electrical power, and greater maintenance. The GAU-18A endures because of its mechanical simplicity, maintainability, and effective ballistic power, a pragmatic tool for complex, mission-critical work. Design refinements tell the story. Barrel length choices balance velocity and handling, while bore treatments extend service life. Feed geometry and chute design reduce jams even in dusty conditions. Those changes were forged by feedback between crews and engineers solving problems in the field. Most of all, the GAU-18A is about partnership. Gunners learn to read an aircraft's motion, feel recoil through the cradle, and correct between bursts. No sensors, no complex electronics, just timing, steel, and trust. That union is why the concept stays relevant. Its adaptability across platforms and straightforward logistics let units deploy it rapidly across Allied helicopters worldwide and in austere theaters operationally. Now for the origin story. Every great weapon has a bloodline. The GAU-18A's roots trace straight back to the Browning M2, John Browning's iconic heavy machine gun from World War II, short recoil operation, belt-fed ammunition, and the massive 12.7 by 99 mm cartridge made it a perfect mix of simplicity and unstoppable power. When helicopters began dominating the modern battlefield, militaries faced a problem. How do you give a flying machine with thin aluminum skin the same firepower as a tank? The M2HB was too heavy, too punishing, and too rigid for a door mount. So engineers didn't reinvent the gun, they redesigned it for flight. They trimmed steel, swapped parts for aircraft-grade alloys, and simplified the receiver. The result was the GAU-18A, around 30% lighter than the ground M2, but still chambered in the same devastating .50 BMG. That weight difference meant helicopters like the HH-60 Pave Hawk or the MH-60 Seahawk could mount two of them without compromising lift or fuel. In short, the GAU-18A was the .50 caliber reborn for flight. The same bullet, a smarter body. The GAU-18A did more than give helicopters a new weapon. It redefined what airborne suppression meant. It proved that high-caliber precision could live alongside delicate airframes if designed with intelligence and restraint. From Afghanistan's valleys to the coasts of the Pacific, it continues to serve in dozens of air arms. Crews trust it not because it's modern, but because it works when nothing else will. Its endurance comes from the same principle that made Browning's original M2 a legend: reliability born from simplicity. Even as modern systems experiment with composite barrels and electronic fire controls, they still borrow the GAU-18A's fundamentals. The rhythm of short recoil operation, the modular receiver, the emphasis on human-machine synchronization. All of it flows from this design. In training footage and combat documentation, the GAU-18A is always there in the doorway, spitting orange fire into the wind. It's not dramatic for the camera. Instead, it's functional art. It's what happens when physics, precision, and purpose find perfect alignment. The GAU-18A turned the impossible into routine, a .50 caliber that could fly. It redefined what helicopters could do, proving that raw power means nothing without control. Every burst from its barrel is precision wrapped in chaos, engineering balanced on a blade's edge. If you enjoyed this breakdown, hit subscribe and stay tuned, because next, I'll dive into another masterpiece of airborne engineering and the power hidden beneath its design.